This was a study of mice done by Mace et al. In this study, they used ultrasound technology, and the primary purpose of the study was to see if ultrasound technology would be as effective at mapping brain activations as fMRI technology. However, they also did a second part of the study, and in the second part, these were mice that were, their heads were stabilized on a platform, and they were looking at a screen, and a fear response was conditioned in them with the use of loud sounds. So using the ultrasound technology, they could see that the amygdala was activated and overactivating as a result of the fear response. What they did then was they had bars move across the screen in a way that would simulate the eye movements that we use in eye movement therapies, bilateral eye movements. So the eyes of the mice were moving from one place to another. This was caused by what's called the optokinetic reflex. Now, this is an innate behavior of the eyes, so that when we look from one location to another, the new image is not stabilized until the optokinetic reflex is stimulated, and then it comes into focus. Using this mechanism, they were able to study how the mice moved their eyes and whether the deactivations in the amygdala occurred or not. They tested 87 different regions in the brain. They were looking at each one of these regions using the ultrasound technology. And of course, when we use fMRIs or ultrasound, we're looking actually at increase in blood flow or decrease in blood flow. It's not an electrical activation, right? So they looked at 87 regions, and what they found was in 83 regions, when the eye movements were occurring, 83 of the regions were activated. However, 4 of the regions were deactivated. And where do you think those 4 regions were? They were in the basolateral amygdala area. Now, this is an indication that eye movements themselves in a threat environment can reduce activations in the amygdala.